Factoring quadratics when a equals 1. Okay, in this concept we're going to learn about factoring quadratics that look like this example for number 1. Notice here that our x squared does not have a coefficient. So when your x squared doesn't have a coefficient, you're going to follow this method. In your next video, we will learn how to factor when x squared does have a coefficient. It's very important for you to notice the difference between when it does and when it doesn't. Okay, so the way we're going to factor this is we are just going to find out what two numbers multiply to positive 12 and add to positive 8. So I'm getting the 12 from right here. It's my last term. It's considered my C term. So standard form says that it's ax squared plus bx plus c. So here my a is 1 because there's not a coefficient, my b is 8, and my c is 12. So I'm finding out what multiplies to that c term, my 12, and what adds to 8. So I just need to find two numbers that satisfy this. So the way I'm going to find it is I'm going to start by writing out my factors of 12. So factors of 12. 1 times 12 is equal to 12. 2 times 6 is equal to 12. And 3 times 4 is equal to 12. So I just need to look at these pairs and say which of these adds to 8? Well, 2 and 6. So 2 times 6 is 12, and 2 plus 6 is 8. So my factored form here is going to be x plus 2, x plus 6. So if the problem is asking you to factor, that's what you write. That's your answer. If the problem is asking for you to solve, you take each of these sets of parentheses, you set them equal to 0, and you solve for x. So I get x plus 2, I set it equal to 0. X plus 6, set it equal to 0. So to solve the first one, I'm going to subtract 2 on both sides. I get x equals negative 2. The second one, I'm going to subtract 6 on both sides. I get x equals negative 6. So my solutions are negative 2 and negative 6. Okay, for this next one, I don't have a coefficient on x squared again, so I know I'm going to continue to use the same method. I'm looking for what multiplies to 12 and adds to negative 7 this time. So make sure you note that it's a negative 7. So my factors of 12 again are 1 times 12, 2 times 6, and 3 times 4. So I do have a negative going on in this problem because I have a negative 7. So I can put negatives wherever I want in these factors. I just need to find a pair of them that could add to negative 7. That would be negative 3 and negative 4. Negative 3 times negative 4 is a positive 12. Negative 3 and negative 4 add to negative 7. So you are allowed to put negatives in here if needed to satisfy what we're multiplying to and adding to. So my factored form is x minus 3 times x minus 4. Again, if the problem asks you to factor, this is your answer right there. X minus 3 times x minus 4. If the problem wants you to solve, you now need to set each of these equal to 0 and solve. So for the first one, I'm going to add the 3 over, I get x equals 3. For the second one, I'm going to add the 4 over, I get x equals 4. So my solutions are x equals 3 and x equals 4. Okay, for this problem, we're looking for what multiplies to negative 12 and adds to negative 11. So again, we're going to write out our factors of 12. 1 times 12, 2 times 6, and 3 times 4. Alright, so if I look at this, I want to find something that adds to negative 11. And my only pair that's going to work is going to be 1 and 12. I need to think about whether I should make the 1 negative or the 12 negative. I want my answer to come out negative whenever I add them, so it's going to be a negative 12 here. So a positive 1 and a negative 12. So my factored form is x plus 1 and x minus 12. Again, I got the 1 and negative 12 because they both multiply to negative 12 and they add to negative 11. So there's my factored answer. If I'm going to solve it, I would set each of these equal to 0 and I would solve. So I'm going to subtract 1 over and add the 12 over. Okay, for this one, I'm looking for what multiplies to 9 and adds to -6. So my factors of 9 are 1 times 9 and 3 times 3. Now some of you might be thinking, geez, I don't need to write these factors out every single time. I can look at this and tell what the factors are. That's perfectly fine. But if you get stuck, if the numbers are a lot larger than what you're used to, anything, writing out these factors are really helpful. Okay, so looking at my two possibilities, 1 and 9, 3 and 3, the only ones that could add to -6 are 3 and 3, and I'm going to need to put a negative on both of them. -3 times -3 is a positive 9, and -3 plus -3 is -6. So, my factored form is x minus 3 times x minus 3. You could have also written that as x minus 3 squared. Both works. To solve it, I'm going to set each of them equal to 0. Oops. And add 3 over for both. I'm going to get x equals 3 for both solutions. I don't need to write that twice. Okay, I want you to pause your video and try example 5 on your own. Okay, so we had to find what multiplies to -12 and adds to 4. So my factors of 21 were 1 and 21, 3 and 7. And 3 and 7 can make 4 if I make my 3 negative. So I made -3 and a positive 7. Those also multiply to -21. After I had my factored form, which was right here, I set each of those parentheses equal to 0 and I solved. So again, if the problem asks you to factor, leave it right here. If the problem asks you to solve, solve for x. Okay. On this last problem, we're going backwards. We're given the solutions as x equals 3 and x equals -1. We need to write the factors. So, what we've done so far is we were given a problem, we would write the factors, and then the solutions. So now, starting with the solutions, x equals 3 and x equals -1, we go back up into these factored forms. That would be x minus 3 and x plus 1. I get that because recall, we set this equal to 0 in order to get x equals 3. So I'm pretty much just changing the sign. So those are my factors. Now the question is what is a possible quadratic equation? So to get from your factors back up to your quadratic equation, we have to multiply our factors together. Recall, the way that you multiply binomials is through the box method. So this would be x minus 3 times x plus 1. So x times x is x squared. 1 times x is x. -3 times x is -3x. And -3 times 1 is -3. I can combine these two since they are like terms. And my quadratic equation is x squared minus 2x minus 3.